The ASUS Mothership flips the traditional laptop design on its head in order to prioritize cooling and thermals. Rather than having all the hardware under the keyboard, it's all behind the screen. On top of that, we've got some seriously high-end specs here too, so let's see just how hot this machine gets and if we can improve performance with further tweaks. Let's start off with the specs. There's an 8-core 16-thread overclockable i9-9980HK CPU, RTX 2080 graphics, definitely no max-Q here, 64GB of memory and dual channel, and a 17.3-inch 4K 60Hz screen with G-Sync. You can find examples of other configurations and updated prices linked in the description. The mothership is different compared to your standard laptop design. All of the heat-generating components, like the CPU and GPU, are behind the screen. Air is pulled in through the back and exhausted out of 4 vents, 2 near each of the top corners, all of which have thick heat sinks. Inside there are 8 heat pipes which cover both CPU, GPU, and VRM, and apparently ASUS are using liquid metal here, so we're expecting some good results. This design improves airflow as fans aren't trying to suck in air with a small gap between the desk, as is the case with a traditional laptop. This does come at the expense of requiring a stand and meaning that you can only really use it on a flat surface. The trade-off is improved thermals, which are going to be needed for these top-end specs. As you can probably imagine, these specs need some serious power, and that's why the mothership uses 2 280-watt power bricks. You can use one just fine for most tasks, but for full performance when gaming, you're going to need both. The ASUS Armoury Crate software allows us to disable Nvidia Optimus for G-Sync, and I've done all of my testing with Optimus disabled. We also have the option of swapping between silent, performance, and turbo modes. These adjust things like power limits and perform overclocking, and I've tested all modes out here. You can swap between these modes through software, or by using the function and F5 key, the one with the fan icon. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. At idle, both the CPU and GPU were looking fine. The rest of the results are from combined CPU and GPU workloads, and are meant to represent worst-case scenarios as I ran them for extended periods of time. The gaming results towards the upper half of the graph were tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results shown on the lower half of the graph are from running the ASUS CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. Whether gaming or under combined CPU and GPU stress test, the temperatures were lower both in silent and performance modes, as these restrict the power limits, as we'll see soon. Turbo mode raises power limits and performance at the expense of additional heat and fan noise, as you'll hear later. By default, turbo mode overclocks all 8 cores to 4.9 GHz. In my best case test, I pushed this a little further to 5 GHz and applied a small undervolt. This didn't really help thermals in the stress tests, and lowered them by 1 in this particular game. These are the average clock speeds for the same tests just shown. Silent mode had the lowest clock speeds as the power limits were the lowest. Performance mode steps up clock speeds a bit, and then turbo mode saw the largest increase. The 9980HK has a 4.2 GHz all-core turbo boost speed by default, so although the 4.9 GHz all-core overclock in turbo mode is not being hit, we're still seeing excellent results and above best case stock performance. My additional undervolt helped improve things by over 100 MHz more. I couldn't push it too far as the CPU needed pretty much all power it could get at this speed. These are the average TDP values during these same tests. In silent mode, we can see the CPU TDP is capped at 45 watts, then 55 watts in performance mode. In turbo mode, we're capped at 90 watts, and this was our limitation preventing further performance. I was not able to boost the TDP higher in Intel XTU when under a combined CPU and GPU stress test. 90 watts on the CPU seemed to be the limit. Otherwise, we can see the GPU was performing extremely well, averaging 195 watts in the stress test and hitting 200 watts at times. Pretty crazy stuff. Here are the CPU clock speeds while under a CPU-only stress test. The results are higher as the Nvidia graphics are now idle. Turbo mode was able to hit the 4.9 GHz all-core overclock, and my manual tweaks got us to 5 GHz over all 8 cores. Pretty impressive. Here's what we're looking at in terms of temperatures. It looks like my extra 100 MHz overclock to 5 GHz is being offset by the small undervolt. This is shown when we look at the average TDP reported by Hardware Info. The CPU was drawing around 115 watts in both tests, so higher than the 90 watt limit that was observed in a combined CPU and GPU load like gaming. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks from these same modes. For reference, a good i7-9750H can get 3000 points in this test, so we're seeing significantly higher performance with the 8-core i9 in turbo mode, as this overclocks all cores to 4.9 GHz. So how do these changes actually affect game performance? I've tested a couple of games to find out. Shadow of the Tomb Raider was tested with the built-in benchmark at highest settings. There wasn't really much difference at all. My changes only gave us 1 FPS extra, which makes sense given the undervolt is minor and 100 MHz isn't really much at all, especially when we're usually GPU bound here. Far Cry 5 was tested with the built-in benchmark at ultra settings, and the results were similar in terms of average frame rate. What I took away from these tests was that we can still get high levels of performance from silent mode. And while not silent, the fan was definitely quieter compared to turbo mode, as you'll hear soon. If you want to see more gaming benchmarks from the Mothership, check the card in the top right where I've tested 13 games at 1080p, 1440p, and 4K resolutions. As for the external temperatures where you'll actually be putting your hands, at idle the keyboard was cool. Normal laptops are around 30 degrees in this test, but as there are no heat generating components underneath, this one is a cool 20. The screen does get to 30 though. Looking around the back, it's also around 30 degrees too. With the stress tests going, there's no major change to the keyboard, though the screen is about 10 degrees hotter now at about 40 degrees. Looking on the back, we're seeing around the mid-40s, while the exhausts are obviously hotter still. The screen was a little warmer than most others, but as I saw at CES, ASUS are actually placing a metal plate between the heat-generating components and the screen to shield it, so they have obviously considered this. Here's what the fans sound like during these different tests. At idle in silent mode, the fan was definitely still audible. With the stress tests running in silent mode, it was actually quieter than most other gaming laptops while still destroying them in performance, as we saw earlier. In performance mode, it's close to many other gaming laptops, and then in turbo mode, it's very loud at around 59 decibels. You'll definitely want to use some headphones here. The results from the ASUS Mothership are extremely impressive. In turbo mode, ASUS overclock all 8 cores of the 9980HK CPU to 4.9 GHz, and I was able to push this further to 5 GHz stable in a CPU-only workload. In combined CPU and GPU loads like gaming, the CPU was capped to 90 watts, at least long term. The power limit would dynamically change down from above 100. 90 was where it eventually settled after about 15 minutes. The RTX 2080 also runs up to 200 watts, which is also fairly crazy. If you saw my gaming benchmark video, it's no surprise that it's able to outperform the Alienware 51M, even though that has a desktop 9900K CPU. Despite packing all of this hardware, the Mothership didn't get too hot either. Temperatures peaked at 90 degrees Celsius, worst case for the CPU, and 80 on the GPU. Okay, sure, that's getting a little warm, but when you put it in perspective with the performance compared to other laptops, it's very impressive. This is obviously a result of the custom cooling solution. By bringing air in through the back, there's less resistance compared to a traditional laptop design which has less room to breathe. Combined with the 4 heat pipes, 4 thick heat sinks, liquid metal, and 2 12-volt fans, this machine is well equipped to handle this hardware. The downsides are of course that unique design and loud fan noise. To be fair, you can still get pretty good performance with lower fan speeds, but maxed out they do get loud. The custom design means you can't actually use this as a laptop. It's basically an all-in-one desktop replacement that sits on your desk, so it's less flexible in that regard. It's still easier to pack up and travel with than many PCs, though it is on the heavier side and there's definitely a price premium associated with this machine. Here in Australia, we're looking at almost $10,000 for it, which converts to around $6,000 US without taxes. Yikes. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results. Primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements, so don't just blindly copy my settings, and do some testing to find out where your stable point is for best results. It may be possible to improve temperatures by swapping the thermal paste. However, considering ASUS are using thermal grizzly liquid metal, that's going to be fairly unlikely. Raising fan speed and undervolting are much easier for most people to do anyway. And as we've seen, these tweaks did help improve performance and temperatures with the Mothership. Let me know what you thought about the thermals from the ASUS Mothership down in the comments. And if you're new to the channel, you'll definitely want to get subscribed for the upcoming full review to see everything this machine has to offer.